Okay, we're going to get started. Thanks everybody for joining us today. My name is Denise Savageau. I am the chair of the Outreach and Education Work Group for the Water Planning Council's Advisory Group. And we're pleased to have you here with us today. Um, just wanted to check. I just see that Martin Heft joined us. Martin is the chair of the Water Planning Council. Before we start, I'd like to ask Martin. Martin, would you like to say a few words? I might be putting Martin on the spot here. Okay. So, welcome to our webinar today. We have had a series of webinars this year, 2025, on extreme weather and our watersheds. And I think last year in particular, we saw some real challenges. We went from drought to flooding to drought, and that seems to be the way that we're experiencing weather, and the impact on water resources is real. But when we think about those extreme weather events, a lot of times we're talking about flooding, we're talking about drought, and we're talking about the quantity of water. But what about the impacts of water quality? And that's what we want to explore today, is that when we have flooding, and this point is a little bit more obvious, but we're going to get into the details of it. What happens during flooding and how does that impact our water quality? And particularly our focus today is going to be on drinking water supply. And similarly, we have another webinar coming up on October 17th. If you haven't registered for that one yet, and that's going to be focusing on the impacts of water quality on drought. So we hope you will join us for that as well. But today we're going to start with the impacts on flooding. And we have two speakers today, Mike Dietz and Tyler Johnson. And so I'm going to stop sharing my screen. And I'm going to invite Dr. Michael Dietz from the University of Connecticut. He's a senior extension educator there, and he's also a joint faculty member in the Department of Natural Resources and the Environment. He is part of the Center for Land Use Education and directs the Connecticut Water Institute. I'm going to let Mike expand on his what he does and all the important things about the work that he does. We're really pleased to have Mike join us today. So I'm going to turn it over to you, Mike.
Great. Thank you, Denise. So I think that introduction was just fine. I'll launch in. If anyone has other questions, I'm happy to answer them after about some of the work that I do or other things like that. But thank you all for joining us today. We're very happy to be here with you to talk about this very important issue. And I'm going to just go right in here with one quick slide on a little bit of propaganda for some of the folks that I work with here at the University of Connecticut. So one of the centers that I am part of is CLEAR, or the Center for Land Use Education and Research. And some of you are most likely pretty familiar with CLEAR, utilizing some of the geospatial data or other webinars that we host and various training opportunities and things like that. So we've been around for over 30 years and have worked with municipalities across the state on land use and water quality issues. And just wanted to put this up here for others to explore. If you have not heard of CLEAR, check out the website there to learn more about it. Okay, so we're talking today, or I'm focusing today on private wells and the impacts of flooding on folks that have a private domestic well on their property. So I guess we should probably just define what a well is, first of all. So there are two different types that we have here in the state. If you have an older home, there's a chance that you have a dug well. So that's just accessing water that is in the shallow, what we call the overburdened soils, or just saturated soil that is pretty close to the surface of the ground. And the other type of well is a bedrock well, and that's a well that's drilled down into the deeper bedrock that pulls water from fractures that are in that bedrock far below the surface. Both of these wells, the source water for these wells is the precipitation that falls on the landscape. And as that water moves down through the soil, there are things that get filtered out by that soil. Things like bacteria can be filtered out. Other things also, large particles can be filtered by the soil, But then as that water travels down into the deeper bedrock, it can also pick up things and get other things can be dissolved in that water that are present in the bedrock. And those are things like arsenic and uranium and other potentially harmful contaminants. So just wanted to give this little bit of background before we talk a little bit more about this. So dug wells, you probably have at least have seen this at some point, but these types of wells are often not sealed very well on the surface. So I grew up in a house, for example, that had just a well house over a shallow dug well. When we would open up that cover, you would look in, you would see a snake sitting there by the edge. It was very easy for things to fall down in there. So as you would imagine, these types of wells are highly vulnerable to surface contamination on a good day, not even talking about a day when we have flooding. And I'll just put one other note in here, and I'll talk a little bit more about this. Almost pretty much every dug well or shallow well that we've tested for our well testing program has come up positive for total coliform bacteria, and many also had E. coli bacteria. So these are things that are very concerning. I have this one slide in here. Maybe like me, you like to watch horror movies. And whenever I talk about shallow wells, I cannot help but think about one of my favorite horror movies. Does anyone know which movie this is? Feel free to drop this into the chat. I'd like to see if I have any other horror movie aficionados out there. You got it, Ellie, The Ring. Okay, if you didn't get it with that, there's the next one that may have made your skin crawl a little bit like it did mine when I dropped this in here. So just having a little fun there, start things off today. Okay, so I talked about shallow wells, and now the difference with a drilled well is that a section of cast iron well casing is put down through the shallow soil. And so we are now excluding water that's in the soil, that upper shallow groundwater, basically. And the bedrock casing is driven down and is supposed to be sealed into the bedrock so that any surface water that it doesn't have a chance to pass down into the bedrock cannot get into that well, in theory. And so then there's just a borehole that is cut down through the bedrock itself, and that's where water is drawn out of from a pump that's placed down inside there. So I'm going to give you a little bit of information about our well testing program that we've been doing for a few years here at UConn. And then this is just a little bit of background, so it gives me some context to talk about the impacts from flooding. So we've been doing some outreach for the past few years, and this is not just me. This is my former master's student here, Alec Janis. He's at the table there, taking a sample from some folks that were bringing it into one of the events that we hosted. So we've been holding these reduced cost events and testing funded by a USDA grant and through some funding from the Institute of Water Resources. And we've also been taking samples on a walk-in basis here on the UConn campus. We found that many people, when they would get their well, if they were testing their well at all, which most people were not, that the results that they would get from labs were often hard to interpret unless you had an advanced degree in chemistry. So we tried to make this much easier to understand for an average person, with clear indications on there whether their water was meeting the water quality guidelines. And we also are posting Connecticut Department of Public Health's fact sheets that they have on their website, and we've also added a few of our own. To date, we've tested over 800 wells in the state, so quite a few across the state here through various events and folks dropping in samples on the main campus. This is just a quick summary of our exceedances that we found from those 863 wells that we've tested to date. We've had quite a few exceedances of various parameters that you can see on the left there. The one that stands out is the total coliform bacteria on the top, 269 exceedances, which works out to 34% of people that we tested came back positive for total coliform bacteria, 1 in 3. So we've got how many people ended up showing up in our meeting here today? We got 61. So 20 of you, if we tested your water today, would likely come back positive for coliform bacteria in your well. So this is obviously a very common concern. The coliform bacteria themselves are not necessarily harmful to your health, they are indicators that other potentially harmful things could be getting into your well. So I'll talk a little bit more about this. So now let's get into the flooding issue and how this can impact private wells. So if we have water that is ponding near or on top of your well, this is obviously very problematic, especially for a shallow well. These are the most vulnerable because the water can directly pour into there very easily without, any carrying with it along with it the things that can enter in the floodwaters. I mean, if you've seen floodwaters come into your neighborhood, you know what they look like. It typically looks like chocolate milk. And there are lots of other things that are in there that should not be getting down into your well. Things like bacteria, nutrients, other potentially toxic substances that it picked up along the way. So although shallow wells are the most vulnerable, drilled bedrock wells also can be contaminated from floodwaters if that water gets over the top of the casing or even below the surface, which I'll talk about in a second. So first of all, if you see this kind of condition on your property, you should stop using your water immediately. You do not want to be running that well if surface waters are getting in there. And you want to make sure you turn off the power to the well also, because if you flip on your tap by mistake or flush a toilet, that well is going to kick on even though you may not want that water coming in. So the best advice is to flip the breaker and turn that well off. And also, it actually may have been tripped anyway because the wire connections that are in the top of a well are not usually set up to have submerged conditions in there. So that may have tripped the breaker anyway, but if it is not, you should turn that off. So after the floodwaters recede and it's safe to get out there, you should inspect the wellhead, look for evidence of water that had entered the well or rose up over the top of that well, and see if it damaged the well casing, the cap, or anything nearby. The next advice is to chlorinate that well. So there's a procedure for this that Connecticut DPH has on their website. The link is here. And I will mention this too, if anyone is interested in these links, I have a couple in my presentation here. I can drop this into the chat when we're done. So basically you're using the depth of your well to figure out roughly how much water you have in there, and then measuring out a fixed amount of chlorine bleach to mix with some water and dump down into that well. So that's the basic procedure that is then run through all the piping in your house and let sit for a period of time, and then it gets flushed out. So the specifics of that procedure are in this guidance document here. So it's pretty obvious, I think, that the flooding can impact, or how the flooding can impact a private well. But from what we've been finding, even heavier than usual rainfall can actually impact water quality also. So it doesn't necessarily even need to be an obvious flood that's happened on your property. And this also can happen with bedrock wells too. So the reason that this can happen is when we have excessive precipitation, it basically changes the subsurface hydrology. It raises that shallow groundwater table. And when that happens, it changes how water moves underground. And it basically creates a higher pressure condition that can force water into places that it was not normally going when under what we call normal conditions or normal groundwater conditions. So it can force water into different fractures down in the bedrock. It can make water move into different places, even in that shallow soil. So I guess I should start with this. So many people that have a private well in their property also have a septic system. It's not always the case, but for most people it is. And there are regulations that dictate the setbacks between that private well and the septic system. But when we have an excessive amount of precipitation that raises those shallow groundwater levels, that can force water to move into different places that we would not expect it to be going. And so it can be higher chances that water could be, or untreated septic water could be entering private wells, either from yours or someone else's nearby. And one of the main reasons for this is because of where that casing meets the bedrock. I mentioned this before. I'll just zoom in on this for you. So historically, my colleague who retired, Gary Robbins, told me a lot of cases of this, and I've seen this myself, where these points where the casing is supposed to be sealed into the bedrock tend to be pretty leaky. So that allows that surface water or shallow groundwater to enter the well at that point, and that can be very problematic. And this is one piece of data that I'll show you, and then I'll be just setting up for our next speaker next year. These are some of our bacteria results. So what this is 4 years worth of data for total coliform exceedances. So basically finding bacteria present, and E. coli. So on the left side, which represents the blue graphs here, we have total coliform % positive. On the right axis, which are the yellow bars, that's E. coli presence. So the way we read this, the first one there in 2022, 36% of our tested wells were positive for total coliform, 0 were positive for E. coli. I will key you in on 2023, where we jumped up to 45% positive for total coliform and about 7% positive for E. coli. If you remember the summer of 2023, our testing events were right after 2 months when we had twice the normal precipitation during that summer. So we saw this jump, and we suspect this was due to that excessive amount of precipitation getting into the shallow groundwater. We then dropped down in the last 2 years. So kind of interesting findings here. We're going to be exploring these data a little bit more in the near future. So this is just a document from EPA that basically summarizes what I've talked about here, what to do after the flood. So again, I can drop this link in the chat if anyone is interested in this. And now I will just set up our next speaker. So I'll just introduce the concept of stormwater runoff here. So because of the human developments on the landscape, the way we have changed the landscape over the course of the past several hundred years, we have dramatically changed the hydrologic cycle where the water meets the landscape. We've changed and increased the quantity of water that leaves the surface and flows off into our waterways. And we've also influenced the quality of that water as well. And this is commonly called, non-point source pollution. Runoff from agricultural areas is also a type of non-point pollution, but we're going to focus on urban runoff, although Tyler will mention agricultural runoff as well. And these are typically pretty difficult to identify and control in many cases. The main driver here are impervious surfaces, things like parking lots, roadways, driveways, and rooftops, things that water cannot pass through. Water is directed off of these surfaces or down underneath these surfaces into pipe systems and then sent out, in most cases untreated, directly into waterways. So I'll give you one quick example right behind the building that I'm sitting in here on the UConn campus. So this parking lot right here, if we measure the size of it, it's about 48,000 square feet, just over an acre of land of impervious cover. We get 1 inch of rain, 30,000 gallons of water are going to run off of this parking lot. In an average year, that's 1.4 million gallons. Now, this lot has catch basins and piped stormwater infrastructure underneath it. So in my classroom, I would now ask the students, where does that water go? And I would wait to see if anybody had a sense of where that water moves from this parking lot. Well, I'll give you the short answer here. If you use a nice USGS tool called StreamStats, they have a nice little raindrop tracer here. So where I drop this red star that you can see on the map, that was right in this parking lot, this will go down Roberts Brook into the Fenton River and then flow all the way down to the bottom right of your screen. If you see Mansfield Hollow Lake right there, that's where it ends up. So our next speaker, Tyler, might be very concerned about what I just mentioned. And he's well aware of this issue that a good chunk of the UConn campus drains to this side and directly drains into his drinking water watershed. So I will just leave that there and let him follow up on that. But just wanted to illustrate this point that those numbers I gave you are from one very small parking lot here. And there's much more impervious surface that drains to it. And that's not even talking about a flood. That's just a regular rainy day that I just gave you that example of. So other things like construction activities, Tyler's going to talk about this in the watershed, where erosion and sediment controls should be in place. We hope that these things are checked on frequently, but sometimes they fail. And this is very problematic downstream. especially after big flooding events. Towns are supposed to be cleaning out those catch basins, but if they're not kept track of on a regular basis, they can fill up and allow excess sediment and nutrients to go downstream as well. And then there are other things that many of you are aware of, things like road salt that are stored in our watersheds. They should be covered at this point, but in many cases, just the application of those on those roadways can be problematic. And then lastly, fertilizer and pesticide applications throughout the watershed. If these are improperly applied, those can wash directly into those catch basins and go directly out into those watersheds, the drinking water watersheds. So that's basically it for me. There's my email if anyone has questions. Here's the link for our well testing program if anybody would like any more information about that for you. That's there. I can drop that into the chat also. And thank you for your attention. And I'm happy to let Denise introduce Tyler.
Thanks, Mike. And as we said at the beginning, we're going to take questions at the end for Mike and Tyler. But right now we're going to move into Tyler. And I just wanted to remind people that it's also Sustainability and Resiliency Week. And so we're pleased to be hosting this workshop during that week in Connecticut. How do we become more resilient in terms of, making sure that our water quality is kept intact? So that's one of the things we want to be looking at. So here's some of our challenges and what do we do? How do we look at impervious covers? How do we look at controlling non-point source pollution? But I got to turn this over to Tyler Johnson. Tyler works as an environmental technician for the Wind and Water Works organization in Mansfield, Connecticut, and he's been there for about 11 years and has been working the last 3 years in source water protection. So I'm going to turn it over to Tyler. And Tyler, why don't you key up your presentation and we'll get going.
You guys, do it up here. All right. Thank you, Mike. Yeah, I'm lucky to have Mike up at UConn so he can give me a heads up when there's something that may be impacting us down here in Mansfield. So like Denise said, I'm Tyler Johnson. My title here is environmental technician for Wind and Water Works. Obviously on a day like this, you guys probably are not thinking about flooding. It's a beautiful day outside, but I'm going to touch briefly on the flooding and impacts on drinking water quality that we deal with here at Wind and Water Works.
Tyler, just quickly, we're seeing your notes, so I know you can flip that over so we can just see the.
Yeah.
There you go. Thank you.
And it's my first time, so bear with me, guys. Thank you. So just a little background on Wind and Water Works. I believe we are the oldest functioning water treatment plant in the state of Connecticut, built in 1936. So soon after 1936, the treatment facility was built. We obviously had the flood of 38, which this picture down here is a picture of our dam and the actual pump house that's still standing and currently in use here. It's still original and operational, obviously was rehabbed. It was built in 1885. Obviously, this flood was before the Mansfield Dam was constructed, or else we would have had flood control, and this probably wouldn't have happened. So this is our reservoir here on the left, and this is the current pump house that you just saw in that old picture there. A little bit about the Mansfield Hollow Dam. It was built in started to be built in 1949. It was finished in 1952. It's a 14,000 foot long earth-filled dam. The spillway is approximately 700 feet long and about 68 feet high. The dam can provide flood storage for about a 5.8-inch rain event, or equivalent to approximately 14 billion gallons of water. The Mansfield Hollow Dam is located approximately a mile upstream from our Willimantic Reservoir, where our pump station and raw water intake are. Without Mansfield Hollow Dam, we would have a lot of issues when there's flooding, such as pumping, plant control, and mostly important, the treatment process that we go through every day. There's a constant influx of sediment and debris that would be coming down to us without this. Luckily, our three main rivers that flow into Mansfield Hollow Dam deposit most of the silt, sediment, debris that is collected throughout those rivers coming in, so we don't get everything there. If this wasn't here, our reservoir downstream would definitely be filled up with sediment and stormwater runoff, which would essentially decrease the reservoir depth, resulting in warmer temperatures, algae blooms, and extreme amounts of disinfection and turbidity management, which I'll go into what turbidity is in a minute. So this is a brief look at our watershed. So in the top right here, this is a picture of the state of Connecticut. This in the teal here, so the other blue are other drinking water watersheds in the state of Connecticut. The red are community water systems. And this one up here in the teal, this is our watershed, which happens to be the largest in the state, approximately 166 square miles. It spans throughout 10 towns north of Willimantic. This actually is an awesome tool that I use a lot, and I can drop the link in the chat after if you guys want. It's the DPA Connecticut Department of Public Health Drinking Water Map, Source Water Watershed Map Viewer. It gives you a great idea on if you have or are doing a project within a watershed, where it falls, if you need to notify, and who you need to notify, what water company. The majority of it, we are lucky in a sense that we don't have a lot of urban area. The main urban area that we have, obviously, like Mike had mentioned, is UConn, University of Connecticut. I believe mainly the eastern half, it's kind of split right down the middle. The eastern half of UConn is in our watershed. So whenever there's any work going on up there, I always receive notifications on what's going on, so I can go up and take a look and make sure everything's all set. Our source water is made up of three main rivers: the Natchog, which is on the eastern side of the watershed, the Mount Hope, which is more in the center, and the Fenton, which is on the western side of our watershed. These three rivers make up what most people call Mansfield Hollow Lake, or its original name, Lake Navistock, with the majority of its water, along with obviously groundwater infiltration as well. The dam is the only thing dividing this body of water and the Willimantic Reservoir, which the Willimantic Reservoir provides drinking water. Well, that's where we get our source water from, to provide drinking water to all of Willimantic and portions of Mansfield. So some challenges from flooding that we face here. Physical damage to equipment. Obviously, you get a lot of flooding and groundwater coming in through PVC that may damage electrical boxes, electrical motors, pumps. We have 2 raw water pumps that pump into the facility, and we have 2 finished water pumps that pump out into the distribution system. So those are obviously very, very important and crucial for our everyday operations here. So on the left-hand picture here, this is a typical, they call it a trash rack or intake screen, which filters out a lot of the larger debris, so it doesn't get caught up in our pumps or the water wheel which we have. These are pretty crucial, but in high-scale flood events, obviously there's a lot of debris, sticks, trees, vegetation that come down that could clog them up, so we don't get as much water in our raw water plant here. Stormwater runoff. So obviously this is a major concern for flooding and high scale rain events. We have a lot of things to do with fertilizers, which span from residential properties in small quantities to commercial facilities and golf courses, which golf courses obviously use a lot of grub control, pesticides, fertilizers to keep their grasses very clean. But if not managed properly, it's going to send all that down eventually to us. Some others are pesticides, herbicides, fuels, oils, like you can see in the picture at the bottom. Mike had mentioned that it's very important for towns and municipalities to have catch basin cleaning scheduled maintenance throughout the year. We would ideally like them to do on an annual basis and keep track of which ones get cleaned so they can keep them free of debris, free of sediment, free of other contaminants, which will eventually make its way down to our reservoir. Chemicals, nutrients are a big contributor to our pollutants that we receive here from a lot of farms. The manure, has a lot of nitrates in it. There's other stuff from fertilizers, phosphorus, all things that have an effect on our treatment process here. And also, a lot of people aren't aware, but there is a growing concern for PFAS in certain fertilizers that farmers use. And these are called biosolids. So these are another thing that we have to keep an eye on that are now banned in the state of Connecticut for use. So these are impactful for us for, our PFAS testing and all that. So fertilizers, like I mentioned, are a very high concern. They contribute nitrogen, phosphorus, excess nutrients can cause algae blooms along with warmer temperatures and stagnant waters. Some algae, like this algae here, which is referred to as a cyanobacteria, is very harmful to people, to animals, to all forms of life, and very hard to treat in a drinking water facility. As the algae dies, the decomposition consumes the dissolved oxygen in the water column, depleting the water's oxygen, which essentially kills fish and aquatic plants, depleting a healthy water ecosystem. Mike had briefly touched on erosion as well. Erosion has an effect in various amount of ways on water quality. Large-scale rain events or flooding will often cause erosion on all different levels, small erosion, large erosion, which leads to the loss of reservoir storage capacity from the sediment buildup. So as you get runoff from streams along with erosion from rivers, all this sediment eventually makes its way down to us at the end of the stream. This causes turbidity, which I'll get to in a minute. Bacteria overload, which is mainly caused by manure from farms. Contamination from washaway materials from site of erosion on construction sites, whether it be fuel cans, chemicals, or anything near the edge of a riverbank. This is a picture of actually our facility here. This is our auxiliary spillway on the bottom right, and then where the water is coming over, that's our Willaminic Reservoir Dam there. This auxiliary spillway was built as a precautionary measure so that when there's high scale rain events, we don't have as much water coming over the primary spillway here. So now I'm going to talk a little bit about flooding impacts on water treatment, specifically here at the Wyndham Waterworks. The main concern here we have is increased chemical usage. Heavy rainfall and flooding have major impact on, we have a total of 7 chemicals we use here, but primarily it impacts 4 of the 7 that we use here specifically. And those are chlorine dioxide, sodium hydroxide, polyaluminum chloride, which is also known as PAC, and sodium hypochlorite, which we could refer to as hypo, which is pretty essentially a very strong chlorine. So some of the challenges, when there's floods or high scale rain events, there's higher, faster flowing debris filled water, which makes its way down to our facility. No, this is not one of our rivers coming in. It would be a big issue if it was. So this water is known as water that has a lot of turbidity. So in a nutshell, turbidity, I have a picture of a test tube with some very turbid water here. It's the cloudiness or haziness of water caused by suspended particles. These include often organic matter, clay, silt, pollutants, or microorganisms or bacteria. The main problems with turbidity that we have here are it interferes majorly with our disinfection process. It clogs our filter bed media and reduces the lifespan of it. So we have to get our filter bed media, which I'll explain in some later slides, replaced much more frequently, which is not a cheap process. And it also affects the water quality, the aesthetics that our finished water gets put out into the system, which sometimes, customers call and complain about a little bit of yellowish water, which is, it can be iron, manganese, nothing that is harmful. But when we have very turbid water to treat, it's hard to get all of it out. Chlorine dioxide. This is all of our chemicals are dangerous, but this one specifically is very dangerous. It's a pre-treatment disinfectant and pre-oxidizer. So it's more used as a pre-oxidizer here at Wyndham Waterworks. It's a chemical that is made here on site due to its instability in storage. It's used as a pre-treatment chemical. And its primary job here is the process to remove contaminants such as organics, including iron and manganese, like I just mentioned, through the process of oxidation. When it's added and reacts with the particles, pulling them out of solution so they can be bound together in the next step of the treatment process, which I'll explain in a minute. So essentially, the more turbid the water, the more chlorine dioxide that we have to use. Sodium hydroxide, which we call caustic soda, is also very dangerous with a pH of 14. This is injected and used in our pretreatment process as well after chlorine dioxide. So this is the second chemical in our treatment process. Its purpose is to add hydroxide ions, which drives the alkalinity of the water up. So its function is to make the pH most optimal for the next step in our treatment process. So the next step, the chemical is in the process, it works best between the pH of 6 and 7.5. So that's pretty much essentially what this chemical does, is get it in the correct pH range. So polyaluminum chloride, also known as PAC, is a coagulant. In the coagulation process, PAC is added third after sodium hydroxide. And once the negatively charged particles are oxidized and out of solution, they call it, and at the optimal pH, they're able to be clumped together or flocked together to form larger, heavier masses called flocks, as you can see in the photo that I have here. In a pH range of between 6 and 7.5, the charge neutralization and flock formation is the most efficient. So this makes for a most efficient settling of all the particles. So now the flocks are stable, dense, resulting in better sedimentation and filtration. In other words, they will sink to the bottom of the tube settling chambers in the next process and be pumped out to our drying beds where they lay out to dry and are disposed of. The smaller flocks, which don't settle, will have to go through our filtering process in the filter beds through our trifecta of filter bed media. So these are three different diagrams of what treatment plants can use. We use more of a mixed media on the right. So we have, from the top down, we have GAC, or which is granular activated carbon. Then a layer below that, we use sand. And then below that, we use filtered garnet. So these are all the filter bed media that if we don't have an optimal treatment process, that they get clogged, they get disturbed, and we have to replace more frequently, which is very costly. The last chemical in the process, which flooding can impact, is the sodium hypochlorite, or known as hypo. This is essentially, like I said, a very strong chlorine with a chlorine percentage of approximately between 13 and 15%, whereas your standard home bleach has content of 1 to 2%. It is added post-filtration as a disinfectant. So stormwater runoff contains various pollutants, like we had mentioned, many containing harmful bacteria and microorganisms. So the more bacteria that you have in your water from the turbidity and all the stormwater runoff, the more money it is for us to use here. This process is very simple and identical to cleaning your house with bleach, just on a much larger and more potent scale. So a quick recap, flooding carries pollutants into the rivers, which we have 3 of. Those rivers carry the pollutants to the reservoir, contaminating and destroying the ecosystem and raw water quality here, which makes it essentially much more difficult and costly to effectively treat and produce potable water. This picture here is actually on Bassett's Bridge in Mansfield. So if you guys from around the area notice that they not frequently, but sometimes close the gates, because this was obviously after a large scale rain event. This is the road here. You can see the guardrails and the signs. So they hold back as long as possible until the incoming 3 streams recede in flow. So when they recede in flow after a large storm, because our watershed's so large, they start releasing. So after this, you could bet that we had some very turbid water that was very hard to treat. But we're always in coordination with them. So when they do release, we can up our dosages, we can plan accordingly. So that's pretty much all I have here. And like I said, Mike is a great asset to have. He's actually taught me a lot down here at Wyndham Waterworks, and I look forward to working with anyone who wants to know more about it.
Thanks, Tyler. You did a great job for us.
Thank you.
And so now we're going to open this up for questions. You can either put them in the chat, or if people want to raise their hand. We've got some folks who are monitoring both. So why don't we start? I think we've got something, a question. Well, Martin, do you want to ask the question, or you want me to read it from the chat? We're more than happy to have you come online. Okay. What are the top 2 changes you would make to watershed-based plan this year to handle climate-driven risks? Maybe a monitoring change and an implementation change. What do you think needs to happen there?
That's a tough question. Tyler, you have any thoughts on this? You guys deal with any watershed plans? I know there's a NatJog plan, I think. I've been seeing postings from that group, but are there any that
Yeah.
you participate in directly?
Yeah, actually we just became involved with the ECCD and are working on the NatJog based watershed plan.
Yeah.
So these are things that I'm learning. I can say top two changes that would make to a watershed based plan, Jay. Um, I would say anything that can any infrastructure that can filter water, that can filter high scale rain events such as, riparian buffers, rain gardens, a pervious surface like you had mentioned. Um, those things would be very helpful. Off the top of my head, I mean I can get back to James on this.
Yeah, I'm gonna jump in because um, I work in this, and just to let folks know that the legislature passed some important pieces of legislation this year, including looking at nature-based solutions and ecosystem services they provide. So one of the things we can look at is when we're doing watershed planning is what is the nature-based solution? So such as riparian areas, forests, healthy soils, making sure we're doing all of that. So there's actually a work group looking at that, and we'll be looking at specifically how does that help with our, provide resiliency for our drinking water supplies. So, and just quickly, ECCD is the Eastern Connecticut Conservation District. So,
Yeah, I
and
guess
yeah, go
I'd like
ahead,
to just
James.
clarify. Yeah, I just like to clarify. It's these events are obviously much more extreme than your general storm, and how we plan for them as because they are becoming more regular. I think the question we should be asking too is we work with minimum standards quite frequently. We ask ourselves what's the minimum buffer size, and we say, okay, that's got to be 30 feet, 100 feet. And maybe what we need to be starting to think about is enhancing those buffer sizes to be even larger. We maybe need to think about our rain gardens, even in our own backyards, being slightly larger, having greater capacity. But I guess what I was thinking about is, when we think about parking lots in particular, and Mike's example is a great example of that. My question is, we how often are we planning for 200, 300-year flood events when planning those infrastructure that supports the rainwater capture that runs off of those parking lots? In some cases I've seen it, but in most cases I haven't, and I'm just wondering if that's something we need to start enhancing, especially in the municipal level.
All very good points, James.
Yeah, so
Um,
I will just add in that, as you know, the state of Connecticut did just adopt new stormwater standards. So most of our infrastructure now is under the old standards, but we now have new stormwater standards that is taking into consideration some of this, where the volume of stormwater runoff is now increased, and that's a big change. That said, there's a lot we need to do, looking at stormwater infrastructure, but also, so for example, Tyler mentioned the dam, the Mansfield Dam, and, is that going to top more? It's like it provides a lot of storage, but can it, a 5-inch storm or a 5.5-inch storm, they're getting more and more normal. So, looking at that from our flood control structure. So great, great question. And it is, I think so, I think it is being looked at. So I'm just going to put that out there. So go
Thanks,
ahead,
Denise.
Mike.
We do have a couple other questions here too.
Sure. Yep. Go
Um,
ahead.
so, Allie, your question about the percentage of private wells that are dug wells in Connecticut, I was estimating between 5 and 10%. and I just sent Alec. So Alec is the one who did his master's work on the well testing project here. He's now working as an extension educator for us full-time on this project and our new PFAS project that's starting. And he very quickly looked into our data and told me it was 57 dug wells out of 868, which is 6.5%. So there you go, Alec.
Thank you very much.
Yeah, no problem. And thank you, Alec, for that quick turnarounds. And he's a whiz in those data sheets. So thank you again. And Alicia, can increased precipitation and stormwater runoff impact subsurface sewage? Yes, so I did talk a little bit about that and impact adjacent private wells potentially. And so if so, what would be the impact of weakening regulations for subsurface sewage? Is there some proposal to weaken like our setback distances or something? I wasn't aware of that, but there is, Denise?
The proposal isn't out yet, but there's legislation looking at making sure that or looking at subsurface disposal to see about alternative methods, and also looking at how we can advance affordable housing quicker. So and
Yeah.
we're hoping that they make sure that they take all these considerations you're talking about, Mike, into consideration, because it's a problem.
I definitely would take these things into consideration when evaluating something like that. I do not think we should be weakening those given the things that we've seen. I guess one thing I forgot to mention while I was talking about that, this is what we tell people, this is a key point that we try to make, that these things can change over time. The quality of the water in their well can change over time. So just because the only time their test is required is when that well was installed and people think, oh, it was fine then, I'm good to go for 20, 30 years. This can change year to year and even, month to month, depending on what's going on with the weather and how the well and the bedrock, the casing are and that sort of thing. So it's really important to test frequently, which is what the Department of Public Health recommends.
I agree with Mike. We should not be weakening our regulations at all. From a water department standpoint too, we should, if anything, we should be strengthening them and raising the distance of certain setbacks, to protect the health of our waters.
Good point. Thanks, Tyler. Any other questions?
Any other questions? We don't have to put it in the chat if anyone wants to raise the hand. And I just want to apologize. I saw that question was from Jamie. I was going through the questions very quickly, and the question I had was from Jamie, who came on, James, who came on. Thanks, James, for clarifying that. And I had put Martin on the spot, and it wasn't his question at all. So sorry, I scrolled too fast on that and had the wrong name come up.
Right, we good to go then?
Any other questions? Well, thanks, everybody. Oh, go ahead, Graham. You can jump in, and thank you for putting everything in.
Great job, guys. This is an awesome presentation. Thank you so much for bringing this to us.
Thank you, Graham. Appreciate it.
Topic, right? You only care about your water when the source is polluted or it runs dry.
You got it. Exactly.
Very, very important.
Yeah.
There's no development without water, folks.
Yeah, and thanks, Graham, for putting everything in the chat. He's always the best one putting it in the chat. So
least I could do.
So
Awesome.
having no further questions, we'll be ending this conference.
Denise, you were going to drop the link in for the next webinar?
Oh yeah, that's right. We're going to put this in. I'm going to share my screen again so people can take a look at that.
There you go. Kelsey got it.
Kelsey got it. But our next webinar is on October 17th. I'll leave this up as people are leaving the room, because you can get the chat and register a couple of different ways, but it's in the chat. Also, you can take a photo of the barcode there, the QR code. Thanks, everybody, and we'll see you next time.
Thank you so much.